Sathyabama Institute of Science and Technology.
I'm Dr. Abitha Memala, professor working in the Department of EEE, Sathyabama Institute of Science and Technology, Chennai. In this video lecture, I'm going to talk about the construction of three-phase induction motor. Under this topic, we are going to discuss about the introduction of AC machines, classification of AC machines, construction of induction motors, and classification of induction motors. First, let's see the introduction about the AC machines. Electrical machines are electromechanical energy conversional devices. The electrical machines are classified as electrical generators and electrical motors. Electrical motors convert the electrical energy into mechanical energy. Electrical generators will convert the mechanical energy into electrical energy. AC machines are classified as synchronous machines and asynchronous machines. Synchronous machines can be further classified as synchronous generators and synchronous motors. Asynchronous machines are classified as induction generators and induction motors. Our topic for presentation is induction motors. Induction motor construction we are going to see. In induction motor, we have two important components. The first one is the stator, the other one is the rotor. Stator is the stationary part and rotor is the rotating part. This one is the stator, which has the hollow cylindrical shape, and this one is the rotor, which is placed inside the stator. Stator is the stationary part and rotor is the rotating part, and it is free to rotate. Next, we are going to see the cut view of induction motor. From the cut view of the induction motor, we are seeing the main components of induction motor. That is, we have stator, stator windings, rotor, rotor windings. We have a frame as the outer part. We have the cooling fans and the shaft and bearings. These are all the important components which are present in induction motors. This is a cross-sectional view of the induction motor. The outer part is the stator core, which is also called as stator laminations. Stator core has the stator slot in which we will be placing the stator windings. Inside the hollow cylindrical shape, we are having the rotor. Rotor has rotor core and rotor slots. Inside the rotor slots, we will be placing the rotor windings. Between the stator core and the rotor core, air gap is there, and the rotor is placed on the shaft. It is mounted on the shaft. Now we are going to see each part of the induction motor in detail. The outermost part of the induction motor is frame, which gives the mechanical support for the stator as well as the rotor. It is made up of casting material, and next one is the stator. Stator consists of steel frame. It is going to support hollow cylindrical core. It is made up of thin sheets of steel, and it is laminated and they are stamped together to form the stator core. Stator core has stator slots in which we are placing the stator windings. Stator windings are of two types. One is star connected and another one is delta connected. Next, let's see about the rotor. This is the construction of the rotor. Rotor is also made up of the silicon steel laminations, and they are made up of thin sheets. They are laminated and stamped together to form the rotor. Rotor has rotor core and rotor slots and teeth. In rotor slots, we are placing the rotor windings. In rotor, we are having the driving end, another one is non-driving end. Driving end is connected to the load side and non-driving end is connected to the cooling fans. And we have the bearings for the free movement of the rotor. These are all the sample diagrams for stator windings. This is your stator winding and this is your rotor winding. Next, let's see the construction of the rotor, different types of rotors. We have two different types of rotors. One is squirrel cage rotor, another one is slip ring rotor. Squirrel cage rotor is also called as cage rotor. In rotor slots, copper bars or aluminum bars are placed, and these are all the copper bars or aluminum bars which are placed parallel, and at the end we have the end rings for shorting all these copper bars. This arrangement is similar to squirrel's cage, so it is called as squirrel cage induction rotor. So this is the shape of the rotor we have. Instead of having the parallel arrangement of the copper bars are skewed. The reason for skewing the copper bars are to reduce the humming noise and to provide smooth torque for different positions of the rotor and to reduce the magnetic locking between the stator and the rotor. Next type of rotor is slip ring rotor. This is also called as wound rotor. Wound rotor has three-phase windings which are placed in the rotor slots. These can be connected in star or delta connected way. These are taken out with the help of the slip rings as well as brushes, and they are mounted on the shaft. So this is the sample diagram what we are having for slip ring rotor. These are all the windings taken out and mounted on the shaft, and we can connect these windings along with the external resistances so as to control the speed of the induction motor. Next, shaft and bearings. Bearings, we have two set of bearings to support the rotating shaft, and we have the steel shaft which are used for transmitting the power from the motor to the load. We can classify the induction motor based on the rotor construction into two different types. One is squirrel cage motor, another one is slip ring motor. Squirrel cage motor is also called as cage motor. Slip ring induction motor is also called as wound rotor induction motor. Thank you for watching this video. In the next presentation, we are going to see about the working principle of induction motor.